Hi, my name is Layla Unger, and the research that I'll be presenting today I conducted along with Olivera Savic and Vladimir Slitsky. And if you'd like to reach me, please email me at unger.114@osu.edu. So today I'll be presenting a talk titled Simple Mechanisms, Rich Structure, Statistical Contributions to Semantic Development. So our knowledge about the world plays a really fundamental role in many of the cognitive processes that we rely on every day. So it's foundational to our ability to reason, communicate using language, plan for the future, and so on. And our knowledge can support all of these cognitive tasks because it's not merely a jumble of stored information, but instead it forms an organized semantic network of concepts denoted by words that are connected to each other by meaningful semantic links. So for example, our knowledge of the concept juicy is associated with our knowledge of apples and with our knowledge of pears. And in addition, our knowledge of apples and pears is also linked because they both belong to the same stable taxonomic category of fruits and therefore are meaningfully similar. So the question that I'll be investigating today is, how do these semantic networks develop over the course of childhood and into adulthood? And I'll be exploring a potentially key role for statistical regularities of word use in language in driving the development of these vital semantic networks. So this is motivated by a proposal initially proposed by Slitsky, Yao, and Dennis, in which co-occurrence regularities in language play a key role in the development of semantic networks. So for example, our knowledge of juicy can become associated with our knowledge of apples because the words juicy and apple reliably directly co-occur, such as in sentences like, "I'd like a nice juicy apple." And in the same way, our knowledge of juicy can become associated with our knowledge of pears because the words juicy and pear reliably co-occur, such as in, "That store has really juicy pears." And importantly, this is something that you can get kind of straight from the input. So if you hear juicy and apple directly co-occurring, that can foster a link between the concepts juicy and apple. And because you can kind of get this straight from the input, this proposal suggests that associative links that can be formed based on direct co-occurrence are present early in semantic networks and continue to play a key role throughout development. But you may have noticed, looking at these words, that these direct co-occurrence regularities are not the only ones that are present in language. Instead, apple and pear share each other's pattern of co-occurrence with juicy. And this kind of shared co-occurrence regularity is true for many words like apple and pear that are taxonomically related and similar in meaning. Therefore, you can potentially form taxonomic links based on shared co-occurrence regularities. But in contrast with direct co-occurrence, shared co-occurrence is something that you don't get straight from the input. Instead, you have to sort of integrate across separate episodes of direct co-occurrence in order to detect shared co-occurrence and thus form these taxonomic links between words like apple and pear. And because taxonomic links pose this potentially added challenge, the proposal suggests that taxonomic links that can be formed based on shared co-occurrence should only emerge more gradually over the course of development. So the goal of the research that I'll be presenting today is to test these predictions, specifically that associative links that can be formed based on direct co-occurrence emerge early and are only gradually supplemented by taxonomic links that can be formed based on shared co-occurrence. So to do this, we used an approach in which we identified pairs of concepts that are associated, i.e. that their labels reliably directly co-occur in language, pairs that are taxonomically related, as in they belong to the same stable category, such as fruits, and pairs of unrelated concepts. And we'll be measuring semantic links between these concepts in both young children, 4 years of age, and adults. And critically, we're going to be using implicit measures of these semantic links between concepts that don't require participants to reason about them, because we don't want our measures to be contaminated by developmental changes in things like ability to reason. So how did we identify these pairs? So we identified associated pairs as pairs of words that reliably co-occur in a 7-word window more often than would be expected by chance in recordings of speech input to children. And we identified taxonomic pairs as pairs belonging to the same category, such as fruits, that have close similarity in meaning, which we measured from something called WordNet, which is a database of words and their definitions that was developed by lexicographers. And if anybody has any questions about these two measures, I'd be happy to talk about them more at the end of the talk. So using this approach, we end up with a set of pairs including associated pairs like bottle and baby, taxonomic pairs like pig and bear, and unrelated pairs like crayon and frog. And as a reminder, we're going to be using these pairs in order to test the prediction that associative links that can be formed based on direct co-occurrence emerge early and persist throughout development, whereas taxonomic links that can be formed based on shared co-occurrence only emerge more gradually over the course of development. So in a first experiment, we studied this using a cued recall paradigm. This paradigm is very simple. Here, participants simply hear a pair of words such as baby and bottle, and then at test, they're prompted with one word from the pair, and their job is to recall the other word from the pair. And the logic here is that we're going to be measuring associative and taxonomic links based on better recall accuracy for associative and taxonomic pairs versus unrelated pairs. So the idea, for example, is that if baby and bottle are linked in your semantic network, then you should recall bottle better when prompted with baby than you do for an unrelated pair, such as crayon when prompted with frog. So here I'm going to show you recall accuracy for children on the left and adults on the right. And keep in mind that since this is recall accuracy, chance performance would be 0. And we saw that children recalled unrelated pairs about 20% of the time, but they were substantially more accurate for associative pairs. However, they were pretty much no different for taxonomic pairs. Whereas in contrast, adults were better for associative pairs and for taxonomic pairs. So we're seeing evidence of associative links in both children and adults, but only evidence of taxonomic links in adults. And this pattern is conforming to our prediction that associative links are present in semantic networks starting early in development and continuing into adulthood, whereas taxonomic links only come to gradually supplement associative links. But we don't want to conclude this from just one experiment, so we conducted a second experiment using a totally different paradigm called match verification. Here it's another simple paradigm where participants simply hear a word such as baby, and then they see a picture, and their job is to simply say whether the picture is of the same thing as the word. And critically, just in trials where the correct response is no, we manipulate whether the word and picture come from an associative pair, a taxonomic pair, or an unrelated pair. So we'll be measuring associative and taxonomic links based on slower correct no responses for associative and taxonomic pairs versus unrelated pairs. So the idea here is that if baby and bottle are linked in your semantic network, you should be slower to say, no, that picture is not the same thing as the word than for an unrelated pair such as crayon and frog. So again, I'm going to be showing you children on the left and adults on the right, but this time the y-axis represents reaction time for correct no responses. So children's responses were slowed for associative pairs, but not for taxonomic pairs, whereas adults were slowed both for associative pairs and taxonomic pairs. So again, we're seeing a pattern of results consistent with the prediction that associative links are present in semantic networks, starting early and persisting throughout development, whereas taxonomic links only gradually come to supplement associative links. But at this point, I want to highlight a potential limitation of these two experiments. So you could say that both experiments use paradigms that might not be sufficiently sensitive to really detect all that's going on in a participant's semantic network. Specifically, we only kind of get a single snapshot of whether, for example, baby and bottle are linked based on accuracy in experiment 1 and reaction time in experiment 2. So it's possible that we might be missing, for example, taxonomic links in children. So in order to address that possibility, we conducted a third experiment using a visual world paradigm. Now this paradigm is a little bit more complicated, so I'm going to take a little bit longer to walk you through it. So in this paradigm, participants saw a pair of target pictures, that were unrelated to each other, such as apple and bottle. And while they saw those target pictures, they heard a prime word. And that prime could either be an associative prime for one of the targets, such as tree for apple or baby for bottle, or a taxonomic prime from one of the targets, such as grapes for apple or bowl for bottle, or an unrelated prime that was unrelated to both targets. And we measured looking at the targets while participants heard the word. And we measured associative and taxonomic links based on greater looking at a given target when it was accompanied by its associative or taxonomic prime versus its unrelated prime. I really want to emphasize here that we're always going to be looking at how much a participant looked at a given target picture, such as apple, and how that looking varied depending on whether they heard an associate or a taxonomic versus an unrelated prime. So we're never going to be comparing, for example, how much they looked at apple versus bottle. It's always looking at the same picture and how that varies according to the type of prime. And this is an important characteristic because it means that our measure of semantic links can't be contaminated by visual characteristics of the target stimuli. So during the trial, participants saw the targets themselves for 500 milliseconds, and then they heard a prime word, and we recorded their looking for 2 seconds following prime onset. So now again, I'm going to show you children on the left and adults on the right, but this time I'm going to be showing you how looking at targets changes over time as a function of the type of prime that the participant hears. So I'll be showing you one line for how much more they look at a target picture when accompanied by its associate versus its unrelated prime, and another line for how much more they look at the target when accompanied by its taxonomic versus its unrelated prime. So here chance level is 0, which would indicate that a participant looked the same amount at a target picture regardless of whether they heard an associative or taxonomic versus an unrelated prime. So in children, we saw that both types of primes prompted looking at target pictures, but the effects were much stronger for associative primes. So kids looked more at a given target picture when accompanied, more and for longer at a given target picture when it was accompanied by its associative prime than when it was accompanied by its taxonomic prime. Whereas in adults, we saw similar effects of both associative and taxonomic primes. So children showed stronger effects of associative versus taxonomic, whereas by adulthood, the effects of associative and taxonomic primes were similar. So again, we're seeing a pattern that conforms to the prediction that associative links emerge early and persist throughout development, whereas taxonomic links only gradually supplement associative links. But experiment 3 gives us a more nuanced picture of what's going on because we have a more sensitive measure, and we could detect that even in young children, taxonomic links have already sort of started contributing to semantic network organization, but only some point between 4 years of age and adulthood do they become similar in strength to associative links. So to present an overall summary, the motivation of this research was to test an account of the development of semantic organization, in which statistical regularities of word use play a key role in driving the development. So we tested and found results conforming to the prediction that associative links that can be formed based on direct co-occurrence emerge early and continue to play a key role in semantic networks throughout development, whereas taxonomic links only come to supplement associative links with development. So what are our next steps? So I want to highlight a key prediction of this account that statistical regularities of word use play a role in the development of semantic organization. And that prediction is that an individual's ability to form new semantic links from direct and shared co-occurrence regularities should drive the development of their semantic network. And in the talk actually just following mine, my colleague Olivera Savic will be presenting evidence that's consistent with this prediction. But in the future, we're going to be really directly testing this prediction that the development of the abilities to form these semantic links from co-occurrence regularities predicts the development of an individual's semantic network. So with that, I'm brought to the end of my talk. Thank you very much for listening, and I'd be happy to take any of your questions.